Around July 18th. Alright, let's do this. Non-overlapping intervals. Given intervals, return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Interesting question. Alright, let's take a look. So, example, we have 1 to 2, 2 to 3, 3 to 4, and 1 to 3. So now remove 1 to 3. Remove 1. 1 to 2, 1 to 2, 1 to 2. 1 to 2 is 0. Okay. Alright. Usually we sort, let's sort based on front. Okay, so it's basically we have 1 to 2, 1 to 3, 2 to 3, 1 to 3. 3 to 4. And then we need to see how many we should remove to make the rest intervals non-overlapping. Isn't this the same as asking for the longest non-overlapping subsequence? Right? That's the same. So maybe we can do it differently. The longest non-overlapping subsequence. So if we want to do non-overlapping subsequence, what we need to do is, let's say we want to see dp, okay? Let's say dp index is give me the longest non-overlapping intervals ending at index. Okay, if that's the case, then I have a front, right? Then I just need to find the longest non-overlapping of the previous that ends at 2 or smaller, right? So we can we can binary search this actually. Right, we can binary search this. I go here because I have, so we sort based on and. So it'll be 1, 2, sort based on and 1, 2, and 1, 3, and then 2, 3, and then 3, 4, right? So when we get to 2, get to this one, let's say, we have a 2. So we need to binary search previous, that's ending because it's sorted by this, so it's fine. So I need to create an index, everything. So a binary search to find, because I'm sorted based on this, it doesn't really matter. We find where, right? And then we have the index. But I want a maximum, right? I want a maximum. So I'd say we find here, is this going to be the maximum? Ending at this. That's not necessary, right? It's not necessarily the max. So what if we do prefix max again? Prefix max. So we record, right? We record the prefix, we record the maximum. So it's not maximum ending at this, it's the maximum ending at maximum. Maximum overall, right? So it's not ending at this index, right? It's ending at the end, ending at this end, right? Ending at the current end. Ending at the current end, what is the maximum? Ending at the current end overall. So the previous one might have a bigger, doesn't really matter. So we need a prefix max, right? So the prefix max index is the maximum non-overlapping intervals with the right ending at whatever that one is. Okay. Okay. I think it makes sense, right? Because every time you hit a new interval, I need to see the previous one. And the previous one, we have something ending at this, right? And I just need the overall. Overall, it doesn't really matter, whichever. Okay, let's try this. So I need bisect right. And I will sort first based on the second one and then based on the first one. Okay. All right. So now we need to have a prefix p max. Okay, p max. Well, the first one is going to be 1. Wait, no, hold on. First one is going to be 0 because for this is going to be 0. Then we're going to say for I in range from 1 to len intervals. Okay, from 1. So every time we get out, we need to, because if this is the same, we store this first. It might be. Yeah, and if it's like to the right, then for this specifically, it will have the longest will just be by itself. Hold on, the longest, it's actually 1. It'll just be by itself. All right, so first we need index equal to bisect right intervals, right? And we have to start, I don't need end, equals intervals, and just intervals 0. Intervals 0, and then key equal to lambda, tuple, and then tuple 1, right? So this will give me an index.
Those laugh at an average of 4.2 times a day, while children laugh at an average of 300 times a day.
We laugh more than that. We look at Jimbo and Jumbo and then we laugh. We say some silly things and then we laugh. Probably not 300 times, but. Okay, so we have this index, right? If index is 0, so current, well, if index is equal to 0, which means nothing in the previous, all right, nothing in the end in the previous is smaller than the current front. When that's the case, then current is equal to 1, right? Else, we need to do index minus 1, right? Index minus 1 is the end that is smaller or equal to the current start. Then we can do p max this plus 1. Actually, current equal to 1, right? If index is larger than 0, and p max and a current plus equal to p max this, right? Once we're done, p max dot append maximum p max dot append maximum p max, the last one, and the current. Right, we got cumulative to here. What's the longest non-overlapping? So blah blah blah. Then we're gonna return p max minus 1, which is the longest, and then len intervals minus this. That's the minimum number we need to remove. All right, let's give this a shot. So this shall be 1. This is 2. This is 0. Intervals. Erase intervals. That ain't right. What the hell? Lambda intervals bisect right. Huh? I don't understand. Oh, intervals I0, my bad. Yep, that looks good. Let's give this a shot. Oh, I've done it before. Alright. Definitely not the best solution. Terrible runtime. And look at this, 64 milliseconds. So we definitely have a better solution for this. 455. DP with binary search. Apparently, this is not the best solution because its runtime is horrifyingly slow, long. Runtime horrifying. Oh, that's O1 log n. 18.67 milliseconds. Oh my god. God, it's slow. Right, we have to find an O1 solution. It's without doubt, it's gonna be O1 solution. 2020, 3 years ago. What's the O1 solution? Not ON. You have to sort, right? You have to sort. And after sorting, you can say, starting from the current one, what is the longest? What is the longest I can create? So I go to the next one, right? I go to the next one. I go to the next one. Okay, or I go to from this to the end, from the current to the end, what is the longest you can create? So I either include this or don't include this. If I don't include this, I go to the next one. If I include this, I include this. Right, now we go for this. And okay, then we'll say if this has been done before, because it could be a situation, you go to the next one, the next one is too large, right? Yeah, you sort based on the front, you sort based on the start. So the next one, if a start is, then it cannot be part. But we want to know what's the longest this can be. What's the longest this can be? This is very similar to the ones we had before, but hold on. We say dp index is the longest non-overlapping starting from this index. Okay, starting from this to the end. So we can take this and call dp index plus 1, right? Or I don't include this, so either 1 plus or dp index plus 1, right? Yeah, it looks like. And dp index plus 1. Wait, hold on. And if I can now take, right? If I can now take, then I'll be 0. So I need a pre, just like the other problem. The same. We say we have the pre, right? So we check the pre. If I cannot, then I should return if I cannot. If I can, if I can take it, then we check if this has been done before, right? Yeah, I think this will be the same as a few days ago. Solution 1, solution 2. So we'll sort again, but this time, so this will be a very similar, this is a very similar solution as a few days ago, right? Days ago, where a seemingly 2D dp is actually 1D, right? Here we use dp index pre to indicate the longest intervals, non-overlapping intervals starting from in the range index towards the end with the previous intervals n as pre, right? Now this seems to be a 2D dp, but the function of pre is just to indicate whether the current interval can be taken. Thus, it does not count as the actual part of the dp. Thus, the dp is only 1D. So we'll sort, but this will be sorted like that, and we'll have a dp will be 1, as everybody can have from this towards the end, and we can always get 1. Right? We can always get 1, but we'll do 0 because we need to see if someone's taken or not. So we'll have line intervals, right? And then we say def dp is going to be index and pre. This one will return an int. Okay, and might as well do len intervals. Right, this will be n. Then we say if index is equal to n, return 0. Okay, that's the edge case. And pre, if intervals index 0 is a start, can be equal to. So if it's smaller than pre, all right, pre-and, that's the pre-and. Make it more explicit. Pre-and, right? We'll make it more explicit. This should be pre-and, pream, pre-and. If that's the case, it's impossible, right? So we cannot take intervals index. Then we simply return dp index plus 1 and pre-and. Right? We cannot take this one, so we'll have to do the next one. Otherwise, if we can take, then we should say if dp index is equal to 0, right? We have not checked index intervals yet, right? If that's a 0, then we say we can do 1 plus dp index plus 1 and intervals index 1. One possibility. The other possibility, dp index plus 1 and pre-end, right? So it's two. Either we take this, because from this to the end, right? We take this, then we try the next one, or we don't take this, then we try the next one directly. So we say dp index shall equal to the maximum of this and this. Okay. Then we return dp index. All right. So we shall return dp from starting from 0. Pre-end shall be minus math.infinite, because star can be very small. And with that, we shall do n minus this. All right, let's take a look. Is this working? It's not working. It's not subscribable. Oh my god. I have the same problem last time. It's supposed to be memo, man. Yep. I mean, this is O1 login again, but maybe it is faster. Ooh. Nope. That is interesting, to say the least. Huh. Didn't work. Didn't work. Maybe we should why would it not work? Yeah, work on something, but does not work on all the things. At TLE, I'm surprised. This should be just O1 login plus n. But it TLE'd. Hold on. Gotta feed the cat. The first method works, but the second method doesn't work. we can have early termination.
Of what?
Of this problem. There is a chance for early termination, but I doubt early termination will make the difference. We're gonna try it. Probably not early termination. Let's take a look again. Gotta be an O(n) solution. Maybe we can try line sweep. Do you think line sweep will work? Well, if we do line sweep, every start with +1, right? So we start, we have 2. So we know we already have overlap. And then, in here, our -1, because this one get escaped, and our +1, which means we'll plus this one, right? So I still have 2. Thanks. So it'll be 2, 1. So line sweep tells you the overlapping situation of the entire thing. Right, that's what it does. It tells you the overlapping situation. But can it tell you the longest non-overlapping? So to make a non-overlap, it should be 1, 0, 1, 0, 1, 0. Right? At least before you hit the start, it should always be 0. That's the non-overlapping. So if it goes through the whole thing, right? If you go through the whole thing, and let's say you sort it first. Okay, you sort it first with a start, and then you'll go through the whole thing, right? Initially you'll get however many, and then you remove something, you plus something. Nah, I don't know. Interesting. Oh, I already see greedy. I think greedy is the solution. Yeah, but I'm gonna check my previous solutions. All right, so this is a previous one. 18 test cases. That's why this one is so slow. It's 58 test cases. It gone from 18 to 58. Jeez. I'm proud of this one, so it's okay. That's the previous one. Oh, the hell. Now I'm gonna take a look at this. How about this one? Nope. This one looks hideous. How about this one? DP. So I think the DP will work. I think this DP will work. But it doesn't work just because the test cases has been increased. Yeah. Well, I think this DP would work. This DP would work 3 years ago. Because there were only 18 test cases. Now the test cases have blown up to 58. And this solution only passes 55 out of the 58. So we have to use greedy. I think this probably is greedy. Greedy. The leftmost must have the least end time in order to allow max capacity for the remaining. That is correct. Therefore, we choose only the non-overlap intervals that have the least end time. The least end time. So it's telling me we sort by this. So the next one, if it overlaps, we ignore. If it does not, we take in. All right, we need to prove. All right, greedy, we need to prove. Greedy, we have to prove it. To prove it, we say if we choose something that does not have a smallest end time, right? We say if we do not have end time. If we include something that do not have the smallest end time in that part, then yes, we can say we can always find something with a smaller end time, then we create a better chance of, it does make sense. It does make sense. So if we take a look from this perspective, because I'm sorting based on this as well, right? End time first. What I'm saying is when you look at an interval, we have the start, and we binary search for the start for some end time that's smaller or equal to the start. But here it's saying if this does not overlap with the previous one, then it's not possible for it to have a better one. Hold on. If we have overlaps with the previous, then it's not possible for this to have the longest. That's basically what it's saying. Because when you overlap with the previous one, you have to skip this, go to the previous. It actually does make sense. It does make sense, especially now you're doing a prefix max, right? You're doing a prefix max. So the maximum will be the end of P max. That is the maximum. It does make sense, right? That's the max. If you do binary search, you find an index before, right? You find an index not the last one of P max. You run the risk of having something smaller. So you always want the last one. Yeah, it makes sense. That makes sense. All right, so it's greedy. That's fine. Greedy is fine. Greedy is fine. Greedy. We want sort intervals based on and. We want to include the longest non-overlapping intervals must include those with the smallest and, because that provides the best opportunity to extend the intervals. This is a simplified, right, version of solution 1, right? Solution 1. It makes greedy makes sense, right? Greedy makes sense because in solution 1 we binary search for a previous position with and smaller or equal to the start of the current interval. However, since we use prefix max, right? Prefix max. As long as the previous position is not the end of prefix max, we always run the risk of obtaining, right? Obtaining something small, obtaining a smaller value than the end of prefix max. Therefore, in order to always, the prefix max. This means when this means the current, if that's the case, right? If that is the case, then the current max will never be bigger than the end of prefix max. In other words, the only way to create bigger, right? To create a bigger sequence of non-overlapping intervals is to use the end of prefix max, which means, right, to find to include intervals with the smallest end. Yes, it makes sense. So sort right, and we'll say max L, max len equal to 0. Then for start and in intervals, pre-end equals minus max dot interval. If s is larger equal to pre-end max len plus equal 1, pre-end equal to end. Return len intervals minus max len. Hold on.
Oh.
Great. We should have wonderful, beautiful dreams. Can't be awesome tomorrow. Oh, get sriracha. Love you. Love you, flying piggy. Oh my god. Alright, let's test this. Solution 3. Yep. How much faster do you think it's gonna be? 1867, 1000 milliseconds. So it's not that slow. Okay, it's not that slow. Wait, you missed a 1. Alright, let's take a look. Greedy. DP does work. Alright, anyway, so we've done this. Let's move on. Let's do one more. Okay, let's do one more. Frequency tracker. Design data structure that keeps track of the values in it and answers some queries regarding the frequencies. Implementing this with an empty array initially. Add adds a number to the data structure. Delete one deletes one occurrence. May not contain number, and in this case nothing is deleted. Has frequency returns true if there is a number in the data structure and occurs. Wait, hold a second. Has frequency returns true if there is a number in the data structure that occurs frequency number of times. Okay, we add. Somebody has frequency 2 is true. Add has frequency 1 false, because we add 1, we delete 1. So nobody has frequency 1. Has frequency 2 false. Add this has frequency 1 true, because this has frequency 1. Interesting. I mean, you can use a counter, right? Every time you add, you increment the counter. Has frequency, so basically everything in the counter. Yeah, if we just do counter, the problem is you can have counter, right? You can have, say, 1 occurs 2 times, 2 occurs 3 times, 3 occurs 2 times, and that. And then if we ask has frequency 2, right? Now we can keep a set of frequencies. So this one is 2 and 3, right? So as frequency 2 will return true. Now when you add again, right? You add again. Oof. So not a set, but another. It's a frequency counter. A frequency counter. This is the value counter, a frequency counter. So when you go add 1, so this will be 3, right? So we know a 2 becomes 3. So this 2 delete 1, the 3 need to be add 1. And if we just delete 1, so a 2 needs to delete 1. And a 1 need to add 1. Okay. So 2 counters. I shall do 2 counters. Vowel C, frequency. Okay, that sounds normal. Frequency. Ugh. VCFC. Okay. All right. Add self.vc number plus equal 1. Ooh. Pre-count equals self.vc number. That way plus equal 1. And we say self.frequency count, self.vc number plus equal 1. And self.frequency counter pre-c minus equal 1. Well, it depends. If self.fc previous, then we minus equal 1. Okay. If it's already 0, then you don't have to minus equal 1. Interesting. Hold on. Okay. So what do we say? A1 minus equal 1. Ugh. It does record. It does record -1, so yeah, I probably shouldn't. Probably have to check. We don't want the -1. Right, because it could be, it's already the start. The start is pre-c has been 0, right? And then 0, that's also 0. So we'll do this, add, delete 1. If it exists, so pre-c equal to self.vc number. Okay. If pre-c self.vc number minus equal 1. If not, then we just don't do it, right? Minus equal 1. Then self.fc self.vc number plus equal 1, because we have frequency this one. Has frequency 0. Will we? Number frequency. No, it will never ask frequency 0. So it's okay. Right, we can do this, it's fine. Even if this becomes 0, we just incrementing 0, it's okay. It's not gonna be a big issue. So this increment, okay. And then the previous, so if self.fc pre-c, then self.fc pre-c minus equal 1 has frequency. If return self.frequency larger than 0. Okay, let's give this a shot. Looks good so far. Try it. Okay, I got this. 2 counters. One for frequency of values. The other for frequency of frequencies. Right. That's it. But the runtime is slow, so I probably need to check the solution. See, there are other better ones. But this is already 01. Right? How much faster can you get, right? 2 arrays. Yeah, I can do arrays. 2 maps. 2 maps. I think nothing more to say about this. All right, so we're done with this. All right, do we do it today? No, I don't want to do it today. Let's do it tomorrow. Okay, so we're done today. I'll see you guys tomorrow. Adios.